Hey there, in this video we'll be going over the getting started section of the Godot documentation. Let's get to it. The introduction section starts off by giving you a general overview of what the game engine is capable of, as well as showcasing some games that have been made with it, maybe so you can get a little bit of inspiration and see that no, Godot is not just for 2D games, you can make really beautiful 3D games in it as well. And it cuts to a general overview of the interface, but we'll be going over this quickly in the next section. And then it quickly goes over the programming languages you can use in Godot, which is GDScript and C#. It ends by letting you know that it would be a good idea for you to have a foundational knowledge of programming so you can get the most out of the engine, before it recommends the Harvard course to you. The Learn to Code with GDScript is really just like a little ad for their Learn GDScript from Zero app. I'm going to have a link to this in the description. I do recommend it. It's pretty easy to get through and it's interactive, so great for learning. The overview of Godot's key concepts is an important part of the documentation because it will help you wrap your head around how Godot works in terms of scenes, nodes, and signals. But I'll just quickly give you a rundown so you don't have to read this. If you look over here, a scene in Godot would be like a prefabrication from like Unity or something like that. It's either one or more nodes put together. So this is technically a scene even though it's just one node. And what is a node? A node is one of the foundational building blocks within Godot. Maybe a good way to think of nodes is that it's an object with pre-built functionality ready to go for you. For example, if I were to grab this icon.svg that comes with the projects and pop it over here, it will become a node over here, specifically a sprite 2D. And this is a child of the node 2D, which is the root node of this scene. All of these nodes within this scene are part of the scene tree. And those are the main concepts that the documentation wants you to understand. However, it would also like for you to know what a signal is. That'll get covered in more depth later on in the documentation. Let's go over the basic interface quickly. Here we have the project manager, and then within here, if you can see the top, there's the asset library. General settings for this can be found here under settings. If you don't want to have the Godot project manager access the internet in any way, you can click right here and set it to offline. Now let's go into my little project, and here is an overview of the interface. I like to go to editor and then click on toggle full screen to get rid of that bar at the top. Your main menu buttons are here along the top left. You can change your different workspaces up here in the top middle. 2D, 3D script, game, and the asset library again. This bar is where your open scenes will be kept, and this main window is what we refer to as the viewport. The viewport has its own toolbar right here. The tools available to you do depend on which workspace you have open. As you can see, they change between the 2D and 3D. These two main sections along the left and the right side are known as the docks, and this bottom section right here, which I can open and close, is the bottom panel. This bottom left dock is the file system browser, and it exists within the root of your project. This dock right here is the scene dock, and it lists your scenes and your nodes. On the right, the inspector, if you have a node selected, will let you edit some of the properties of the nodes and see all their little things. The bottom panel has your output, your debugger, an audio mixer if we had that, animation, and your shader editor by default. The most important thing I think you can pull out of this section of the documentation is that if you were to hit F1, you'll open up the integrated class reference finder, I guess you could call that. And from here, you can just get information about any of the node types and other things. So we can just click on open, and we get everything we need. This is also in the online documentation, but I think for things like this, it's better just to do it within the engine. The most important thing I think you would want to take out of this at this time is that if you use this, you can see the properties that a class has, properties that a node has, the methods that it has by default, and then it gives you some descriptions on them. And they're extremely helpful. I highly recommend you go and read through this whenever you're working. The Learning New Features section emphasizes the use of the Godot documentation itself, as well as the class reference, which I just showed you back in the Godot interface section. It'll also repeat itself about going to the Harvard CS50 course if you want to learn some basic fundamentals of programming and computer science. And then it talks about the Automate the Boring Stuff with Python book, which I've gone through and I actually really like. I do highly recommend that one if you want to learn some basics. It does, of course, use Python instead of GDScript. The concepts that you learn within that book will transfer over to Godot. The learning communities that the documentation will refer to is mainly the Godot forum, as well as the Reddit and the Discord channel. I prefer using just the Godot forum or the Discord. Godot's design philosophy obviously revolves around object-oriented design. Things like nodes would be a great example of that, and then nodes that inherit from other nodes or extend them. Godot also wants to be an all-inclusive package. It wants to have all of its own tools within the engine. The script editor, I think, is a great example of that, as opposed to having to use an external program like Visual Studio. It is open source. It's obviously very important for this engine. I think it's very important in general. It's community driven, but I think that goes without saying because it is open source. You should also note the Godot editor also runs on its own engine, so that's pretty cool. And this also might go without saying, but the 2D and 3D rendering engines are separate. Let's go through their explanation of nodes and scenes together within the editor. Here on the left, we have the scene editor, and to have a scene, we need a node. The node we'll be using is the label node. To get it, we're going to click on other nodes. As I showed you before, on the left, we have the scene editor, and to have a scene, we need a node. And the node we need is the label node. So go to other node right here, and you can just start typing it in. So label. I'm just going to hit enter, but you can also click on create. And there we go. This is our first scene in a way, but it's empty. We want to edit the properties of this label node. Its main property is the text property. So let's just type in here, hey, what up? Now, if I wanted to run this scene, it would ask me to save it first. So let's just save it. Control S, and right into the root directory of the project, we can just call it label.tscn. I'm going to hit F6 to run it, and there it is. Now with this node, we can actually move it around. So if I didn't want it to be in the top left, we can move it right over here and do the same thing. I'll hit F6 to run the scene, and there it is in the center instead. Just a little thing I want to go over real quick. You'll notice that the transform property isn't right out here like it is for many other nodes. Because it's a control node, you'll actually find it under layout, and then transform is right over here. If I wanted to reset it, you just click this little button right next to position. For the creating instances section, we're just going to follow along with the project that they've given us. And in so doing, I will show you how to import projects, but I also want to show you something a little strange. If you go to import existing project, and then you go to this file, you hit open, it's not going to work. However, if you go to browse back, and instead of clicking open, just double click it and it will work. And then click import, fine. It's because I'm using a newer version of Godot. Hit OK, and it'll open up. From within the project, the first thing I want to show you is this ball scene. As you can see here, this ball scene is just comprised of 3 nodes, a collision shape 2D, sprite 2D, and a rigid body 2D. That's important to know. Now that's been saved as its own T scene, which is a text scene. We can go ahead and instance it, or to be more specific, we can instantiate a child scene with it. So to do that, we can click on this main node, click on instantiate. I have a shortcut for Control-Shift-A because I love my shortcuts. Click that, and we can click on ball. As you can see, the ball is in the scene, but we can't really edit its children as we could if we open this up. Now you can if you right click on it and then go to editable children, and now you can, but that's not very important for this section. Now with this ball, we can click on it and we can move it around. If we hit F6 to run it, sure enough, it behaves like a ball, as it should. Hit F8 to cancel this, to close it, I mean. You can do it again. So I'm going to do my Control-Shift-A and open another ball scene. We have 2 unique instances of the same ball, which is that ball T scene. We can actually do this with as many as we want. And then if we hit F6 to run it, balls will fall individually. Now then, because all these balls are instances of the original ball T scene, if we open that up, we can actually edit its properties. Let's set the mass to that, and let's make the gravity 8. I'm going to save it, go back to the main scene, and we'll run it again. Now all the balls are going to behave differently because we edited the original one, of which they are all instances of. The scene instances as a design language section is basically just saying you should do your game architecture around scenes and nodes, and the scene tree, of course, and that you should dismiss the model view controller or use entity relationship diagrams. Don't do that. But for example, you should design rooms. You can instance multiple rooms to make a house. Multiple houses could be your citadel. Your citadel would be instantiated by the terrain. It would belong to the terrain or your world or your stage or your level. Your HUD would then be instantiated by the player. The player would also be instantiated by the terrain. The scripting languages section will basically just tell you that the main scripting language that we use in Godot is GDScript. If you use the .NET version, you can also use C#. And then if you use GD extension, you can use C and C++. But for the vast majority of things, you'll get by, and you'll get by great with GDScript, and that's it. I will be covering GD extension, so C and C++ later on in a different video. Let's go ahead and create your first script together. So open up Godot, click on Create New Project, and we'll call it Creating Your First Script. You don't need version control right now. Hit create. Let's load up. I'm going to go ahead and hit editor, toggle full screen. We need something to attach our script to. So go ahead and click on other node, and we need a sprite 2D on that. There's sprite 2D. Obviously, when you make it, you can't see anything, so we need to give it some kind of texture. And click and drag this icon.svg over to the sprite 2D's texture node. And there you go. You can see it. I'm going to go ahead and save the scene now just so I have it. I'm going to hit Control S and just save it as sprite 2D. That's fine. Now we can go ahead and attach a script to this node. We can do this by right clicking on the node over here and then click on attach script. I have a shortcut that's Control-Shift-Q so I can quickly do it, but this works just as well. Let's click on that. We aren't going to use a built-in script, and we're not going to use a pre-made template for this. So with that, hit create. Now this has made us a .gd file, which is the script. And if we save this, it will also be in our project files, as you can see here. Now we only have the one line in this. It says extend sprite 2D. And what this means is that this class, this implicit class that we have here, the sprite2d.gd file is extending the sprite 2D methods and functions. We can verify this if we, as I showed you earlier, we hit F1, we type in sprite 2D. So this script file that we had is actually extending all of the methods and properties that you can see here. And by extension, due to inheritance, we're also extending everything from the canvas item and the node class. So for our first function, what we're going to go ahead and do is start typing unc. This is the start of our definition for the function. And then we're going to use underscore init for init and hit enter to autocomplete. I'm going to hit pass for now so that it stops yelling at me. Now this underscore init, this is called whenever the game engine initializes this in memory. And by this, I'm referring to this node. And now what I actually wanted to do is we'll type in print and a what up. So when this node is initialized in memory, it's going to run this script. And I can prove that by hitting Control S to save it. And then we'll hit F6. And if you look down here in the output, it does indeed do that. So next, let's go ahead and delete this. And what we're going to try to do now is we're going to try to get our little icon to spin around, and then we're going to try to get it to move. And in order to actually see all this happening, we should actually go back to the workspace under the 2D, and let's just move this to the center. Otherwise, any kind of movement it makes will be sort of cut off by the top left corner. Let's start off by giving it some variables so we can mess around a little bit more. Start off a variable with var, V-A-R, and then the name of the variable. We'll be using speed here. And we're going to assign the integer 400 to it. Do it again, angular speed, and this one is equal to pi. Pi, if you hover over it, is a constant that you may be familiar with. Instead of using the init function, we're going to go ahead and use the process function. We're going to do it in a very similar way. So we're going to define func and then underscore. The underscore lets you know that this is a predefined function that's called by the Godot game engine itself. So we'll do underscore and then process. And I'm going to hit this, I'm going to enter and type in pass so it stops telling me that there's a problem. So what this means is that process takes in a parameter known as delta, and it's a float. If we hover over process, it'll actually tell us a little bit about what delta is. Delta is the time between frames and seconds. Now what this means for you is that delta is a constant, so you have a constant amount of time between frames. If a computer runs faster, there will be less time between frames. If it runs slower, we can say there might be more time between frames, so it's inconsistent. With this delta, we can maintain consistency between frames. So in other words, when we try to make this thing spin around, if your computer is really fast, then it will spin faster. If your computer is slower, it will spin slower. But by using delta, which I'll show you, we're about to do it, we're able to have a consistent spin between machines. And then this section here, following this arrow, says void. That means that this function does not return anything. And to get this to spin, let's go ahead and access the rotation property of the node which is on the sprite 2D. It's just called rotation. And you can confirm this because underneath transform, we have this called rotation. Now here's the formula. Plus and equals angular speed times delta. In case you don't know, this plus equals is just shorthand for saying something like rotation is equal to rotation plus angular speed times delta. It's just so I don't have to keep typing that over and over again. If you want to quickly delete a line, you can go ahead and hold Control Shift and then hit the K key. That'll quickly delete a line for you. If you do Control K, you'll make a comment. So with this, we should be able to make our little sprite rotate like so. So let's go back to 2D. I'm gonna hit F6 and there it is, it's rotating. Hopefully that made sense to you. You may be a little confused about why we even use pi here. It wasn't completely necessary at this stage. I could type in 100 here, save it, go back here, and now let's run it and you'll see it's just gonna spin super fast. So let's just go ahead and put that back. While we're here, although I showed you that you can go over here and confirm what rotation actually is, where it belongs, something else you can do is actually just hold down the control key and then left click and it will take you right to its definition. So this exists within the node 2D. So this is a property of node 2D. And if you can remember, sprite 2Ds inherit from node 2Ds, and that's why we're able to access the rotation. Okay, so now let's get this sprite moving. What I'm gonna do is I'm gonna put my cursor right here after the semicolon, and I'm gonna hit Control Enter to So immediately just go there instead of having to make lines in a slower way. And then I'm going to do it again. And then I'm going to type in Control-Shift-Enter to just add an empty line right below me. It's just neater. And here we're going to define a local variable. This is a variable that exists within this function only. It's not a property of the class like these variables up here. So I'm going to type in var to start the definition of the variable, and then velocity, it equals, and to this velocity variable, we're going to assign a vector2 dot up, and I will explain this in a second, rotated by the rotation, in parentheses, an asterisk, and then speed. So this variable velocity only exists within this function. As for the rotated rotation segment, I think that's easier for me to show you when it's actually in motion. But know that we're going to take this, and this is the direction. We're going to multiply it by speed so we know how fast we're moving forward. Now to actually move it forward, we need to adjust its position. So we're going to do position plus or equal to velocity times delta. As you can see over here, position is also a property of node 2D, and that's exactly what we're going to edit here. We're going to use the velocity that we've defined here in order to move that times delta so that it moves at a constant rate, regardless of our machine. I'm going to save this and then hit F6 to show you what it does. It causes the sprite to rotate around in a circle. And now let me briefly explain what each of the parts are doing. So this vector2.up, if we hover over the up part, you'll see that the vector2 is just 0, -1. And for us, that's basically a direction. You might be a little confused why -1 is up, but I can quickly show you that. So if we look at the position of this sprite right now, you'll see its Y is 306. As we move upwards, it's moving in a negative direction because the top of the screen is 0 in a 2D plane for game development, I guess. It's a basic way of explaining it. If we go above the screen, we're still in the negatives. If we go down, the number moves positively. The rotated rotation is basically just rotating it as it's moving forward. I can show you what these do individually. That might make it a little bit clearer. So if we take out the position, it's just going to rotate like that, put it back, comment this out with Control K. It's just going to move forward. So if you just combine the two, it's going to move forward and it's going to rotate, and then we'll just keep going a little circle. And this delta keeps it nice and constant for us. Not constant, but consistent is probably the word I should be using. Now we're going to move on into the listening to player input section. The documentation basically just has us pop in some code, and I'll try to help explain it. Specifically, we're going to replace this. So let me just do that real quick. Var direction is equal to 0 if input.isActionPressed. And then we're going to use the UI left. Again, I will explain all this in a moment. Then direction is equal to -1. If input.isActionPressed, notice I just type it all together and then I hit enter and it fixes it for me. Then use UI_right. And if that's the case, direction is equal to 1. And then it wants us to comment out these two lines. So I'm going to go over to here. I'm going to hit Control K to comment that out, as well as the position, Control K. And then we need to add in this, which is rotation is plus or equal to the angular speed times direction times delta. With that, if I hit F6, if I press left, I'll go left. If I press right, I'll rotate right. But what does this all mean? Well, let me try to explain it to you. Right here, we're going to set direction to 0. So we're starting off without a direction. And then you should probably note this input is a singleton, so you can access this from almost anywhere, and it's just going to read in input from the user. And then isActionPress is obviously looking for something to be pressed. Now this UI left is one of the default Godot inputs that's defined. And you can actually find these for yourselves by going to Project, Project Settings, Input Map, then click on Show Built-in Actions. And then you should be able to see this under UI left. There you go. So it's left on the keyboard. You can also use a joypad button or joypad access left stick. So then if I press the left key on my keyboard, direction will be set to -1. And then if I press the right key on my keyboard, direction set to 1. And when all this is put together, it causes you to rotate. In essence, the variable that's doing most of the heavy lifting here is the direction one, which we are editing by hitting left and right on the keyboard. I can kind of show you what that looks like. So if we reset the rotation here, basically whenever we hit left on the keyboard, it's going negative like that. And when we hit right on the keyboard, it's going to the right, just like that. The pi and the delta is just helping us have a little nice consistency there. Okay, now let's work on getting this sprite moving up. So we're going to uncomment this, Control K like that, and then replace this. I'll just do the whole thing. See me do it again. vector2 dot 0, 0 of course just being 0, 0 like that, and then if input dot is action press, hit enter, and then I want UI underscore up like that, semicolon, velocity is equal to vector2 dot up dot rotated rotation times speed. And then I just need to fix the order of my code here real quick. Let's go ahead and set this back to angular speed so it's easier to read. And then uncomment this position right here. And then let's go ahead and highlight this, hold down Alt, and I press up on the keyboard to just quickly move that over there. And from here I can hit Control Enter to make some space. We'll save that, hit F6, and if I press up on the keyboard now, I'll move forward. Left will rotate, right will rotate. Can't move backwards yet, but that's easy to implement. We got a little guy that can move around now. Oh, nice. Okay, let's move on into the using signals section. For this, we're gonna have to set up a new scene. You can do this by either pressing this plus sign, or if you're already in the 2D or 3D workspace, you can hit Control N. We're gonna need a node 2D for this, and then we're gonna instantiate the sprite 2D scene that we've already made. Either do this with right click, instantiate child scene. I have a shortcut set to Control-Shift-A, or you can click and drag it from your file browser right onto the node, and it'll appear right here. Then we'll need a button, so I'm gonna left click on the root node and hit Control-A, and then I'm just gonna type in button. There it is, hit create. You can also do that by going to add child node after right clicking. Let's make things a little bit more manageable here. I'll left click on this and move that to the center, and the button is too small. If you wanna center on something after you've clicked on it, you can hit F and zoom in. Let's do that and drag it out. Here, I'm gonna type in toggle motion. You can probably guess what this is going to do. Actually, let's go ahead and make this a little bit bigger. From here, don't forget to save your new scene. So we'll do Control S, and we're just gonna call this node 2D. Before we continue, I'm just gonna go ahead and tell you what the code is about to try to do. So we're gonna have this little icon here move automatically, and then the button will either stop it or let it continue moving. In order to set that up, you can click on the button, then go to node, and from here, look for the pressed signal. You're gonna left click that, connect, select the sprite 2D, which already has a script on it. A script is required if you want to attach a signal. And then from here, we're just gonna go ahead and connect it. We don't need to pick a script out. It's just gonna make one for us. So then hit connect. That's gonna put us in the script window. This function that was automatically generated for us is called a receiver function. And it's important to note they should be named with past tense verbs. And if you want to see more information about it, you can left click on this little icon here. This connections to method icon, I guess you would call it. You can see the source, the signal, and its target. This code should be pretty easy to understand. So we're going to replace this pass with set process not is processing. So this process takes in a Boolean value, so it's usually either true or false. But as you can see here, we're not passing in true or false. We're passing in is processing. Now, is processing does return true or false, depending on if this node is processing or not processing. This will be explained a little bit more later on. It's another way of thinking about if this node's scripts are currently running or not. So basically, if is processing returns true, then this not will set it to false. It will invert it. If it's false, this will set it to true. So in simple terms, it works like a toggle, and it will toggle whether or not this node is processing, this node being the sprite 2D that we made in the previous little lesson. We're not going to worry about input right now, so let's just delete all of this. And if I hit Control-Shift-K, I can very easily delete lines. Rotation can now just be angular speed times delta, so let's get rid of direction. Position is fine as it is. Again, we don't need this input anymore, but we do need this to go back to how we had it before. So let's switch this to up. Dot rotated rotation times speed. And now when we hit F6, it's gonna go in its little circle again. When we click toggle motion, it will stop. Click it again, it will continue. Connecting signals via the editor is pretty handy, but let me show you how you can do it via code. Let's go back to the 2D workspace, and we'll be adding a timer node this time. I'm gonna assume you know how to do some basic things like add nodes now. So this timer isn't gonna really show up, but it does exist here in the scene tree. So what we're going to be doing here is now we're going to have a timer that controls the motion of this little icon here. So it'll stop it every 1 second and then restart it. And to make sure it does that, we're going to click over onto the timer and make sure that it auto starts. After that, let's go back into the script. We can left click it right here. Now what we'll need to do is have a reference to this timer so we can control it from within the script. And then we'll need to connect it to the timer's timeout signal. It emits the signal when its timer times out. Now what I'm about to show you is a little controversial because it's not a very safe way of getting a reference, but this is how the documentation does it. In the future, I'll most likely show you a better way of doing this or a safer way of doing this. Now for this, we're going to use the ready function. So as I showed you before, we do func_ready. This function is called whenever the node is ready. If you hover over it, it'll show you when both the node and its children have entered the scene tree. So I'm going to hit enter to enter the function. We're going to type in var timer is equal to get node. We're going to use this one using the node name timer. So what this is doing is it's finding a node called timer, as you can see here, and then it's setting that node to this variable timer so that we can control it via script. Now you may see why this is a little dangerous. The documentation doesn't mention this because what if we want to rename the timer? Then we'll have to go back into the script and remember that we need to change the name of timer. In the future, I'll show you some alternatives that are a lot safer. Now to connect this via code, we're going to do timer.timeout.connect on timer timeout. Now the editor is going to yell at me. It's going to say identifier on timer timeout not declared in the current scope. That's because I haven't actually defined this function yet. So I'll go ahead and copy this on timer timeout. Let's go to func on timer timeout. It doesn't take anything and it doesn't return anything. So let's put void here. Now this is going to do visible is equal to not visible. I'm going to save it. So as I mentioned before, for signals, we use past tense. So on timer timeout, and this will be the name of the node usually, and then what happens. Now here, visible, we'll just say it comes with this node. What comes with the timer node, it is a property that it belongs to. You'll see it belongs to the canvas item, but I think you kind of understand what it's doing. It basically sets this node to be visible when it is true or not visible if it's false. And as I showed you before with the is processing, putting a not before a Boolean will invert it. So if it is visible, it becomes invisible. If it's invisible, it becomes visible. We've made this timer node and it has a timeout function that occurs whenever it runs out of time, which is this wait time we've set before. I probably should have mentioned that. We're connecting this timeout to another function called onTimerTimeout right down here. So whenever this timer times out, this function that we put right here is going to run. And what that's going to do is it's going to either make it visible or invisible. Hope that makes sense. Let's see it in action though. I'm going to hit F6. Now, the last thing we need to do, I kind of forgot to do this earlier and I should have done it, is that this timer actually needs to be a child of the Sprite 2D node. So you can click it and drag it over there if you happen to do that too. So now that the timer is correctly a child of Sprite 2D, that is a requirement for get node, it looks like. All we have to do is hit F6 to run it, and every 1 second, that will turn visible. After another second, it'll turn visible again. The custom signals section of the Godot documentation is pretty brief, but I'll try to do my best to get the points it wants to make across to you. So not only can you connect signals via the editor and also via code, you can also make your own signals. So let's go ahead and try that now. In a new scene, I'll go ahead and click on 2D scene. Doesn't really matter what it is. We'll rename this custom signal like that in Pascal case for nodes. Then let's give this a script and that should be fine. We're not going to use a template. It's not going to be a built-in script. Now, when you define your own signal, it starts off like this: signal, and then the name of the signal. Health depleted. Do notice the past tense here. And we're going to give this node just a little variable here. Health is equal to 10. And I'm going to save it as custom signal scene. Now that we've defined the signal and we've saved the script, if we make sure to have this node selected, we can go over to the node tab, and right here you'll see it shows our little custom signal right here, health depleted. Now we just need to have a way to emit this signal. So I'll go ahead and make a function. Function is take_damage. It will take in the amount of damage. Health will be minus equal to amount. If health is less than or equal to 0, health depleted dot emit. It's not very important what's actually happening here because we're not going to be using this at all. It's just an example. But here, let's say this is on the player. When the player takes damage, their health will be adjusted by the amount of damage that they took. And if their health is less than or equal to 0, then let's emit the signal that our health is now less than or equal to 0. Now, signals can also take in parameters. So if we go up here, we can type in something like old value, new value. Now that we've defined those parameters, if you look over to the signals tab, you'll see it'll actually show us what parameters the signal takes. And with just a little bit of editing, let's redo this function and we'll actually be able to utilize those parameters. So var old health is equal to health, health minus or equal to amount, health underscore change dot emit old health and health. And then we need to make sure that we rename our signal to health changed instead of health depleted. So now what's happening here is we have a signal, health changed, that takes in old value, which was probably the health, the time it took damage, and then new value, which would be the new health amount. Let's say you have a health bar. You can have the health bar listening. It can connect to this health change signal. So it's listening for when the player's health changes. When it changes, it can then adjust its little red texture to get smaller depending on taking damage. Okay, and that'll be it for this video. The getting started section actually has a your first 2D game and your first 3D game sections as well, but I think those deserve to be in their own videos, especially since I think this one's getting kind of long. If there's anything that didn't make sense, please leave me a comment and I will explain it to you. Thank you for watching. Goodbye.